Hello and good day everyone. We are from Group 1 and today we're going to present about our mini project for the subject KM21603 Applied Thermodynamics, which is steam engine vehicle. Before we start, I would like to introduce our members. The first is MUHAMAD ALIF. We have Idiel, me myself LEONG, MUHAMAD ARIF and also SHEALLY MAIJIN. Creating this mini project, which is making the steam engine car, merges the principle of thermodynamics and mechanical engineering, and thus provides a hands-on experience to understand the energy conversion. This project involves not only designing and constructing, but also researching about a car powered by steam.
Hello everyone, my name is Muhammad Arfan YUSDI, and today I will talk about the principle of operation steam turbine. So first is about the steam generation. The high pressure steam is generated by employing the heat what emitted from a and commonly fueled by coal, oil and any other source of fuel. So next is about the conversion to mechanical work. So the high pressure steam expands and passes through the steam turbine. As the steam expands through the turbine blade, it exerts force causing the turbine to rotate. The rotational of the turbine shaft is the direct result of kinetic energy imparted by the high pressure steam. So this rotational motion is the initial mechanical output. Next is about the exhaust. The steam is expelled out of the boiler on its function of providing the force required to drive the turbine. The exhaust steam is released directly into the atmosphere and resulting in the loss of water and heat. And finally, for the mechanical output, the turbine moves into a rotary motion by the steam that passes through the turbine blades. The rotational motion of the turbine is transferred to the drive shaft, which carries the mechanical energy to other part of vehicle and making the steam vehicle to move.
Hello, my name is Shelly MAIJIN. I will present about the advantages of steam engines. There are four advantages that I will present, which are reliability, fuel flexibility, high torque, and simplicity. The first one, reliability, can operate under a wide range of conditions and are very durable. And the second one is fuel flexibility, which can burn various types of fuel, including woods, coal, and biomass. The third one is high torque, which is capable of producing a high torque at low speed. And the last one is simplicity. Mechanical design is relatively simple compared to modern internal combustion engines. Thank you.
Hello there, ALIF here. So let's take a look on the disadvantages of steam engines. So firstly, steam engines generally have lower thermal efficiency compared to the modern internal combustion engines. Second, steam engines are typically large and heavier than their modern counterparts. Third, steam engines require significant time or a long time to build up steam before operation. Fourth, steam engine need a constant supply of water for steam production. The fifth disadvantage is regular maintenance is needed to manage scale buildup and corrosion in the boiler of the steam engines. And last but not least, traditional steam engines usually produce significant emissions depending on the fuel use.
Hello, my name is Idiel and I'll be discussing about the failed attempts of our steam vehicle. So we made a few steam vehicles as prototypes and we found three main criteria, which is the turbine, the body, and the boiler. For the turbine, sometimes there would be too few propellers or too many propellers, making it too heavy. And the axle is not straight and connection was not good enough to the wheel. This was because we used steel wire instead of what we used in the latest one is barbecue iron sticks. So the turbine was spinning, but at some point the tire was not spinning, so that was a problem. Number two, we have the body and frame. We used wood, plastic, metal, and some other materials. We found that it was too heavy. And number two and three can't withstand heat and not balance. This comes from the fact that we use plastic. Plastic could not withstand the heat that was supplied, and it warped, making it not balanced. Number three, we have boiler problems. Sometimes the boiler that we created produced too little steam, or it was too thick because the heat that we gave out to the boiler was not enough, so it was not able to absorb enough heat. And the output boiler produced too little torque, meaning the rate of steam that was produced did not give it enough torque so that it could spin the wheels. Okay, so next we'll be looking at the construction of the steam vehicle. This could be split in also three criterias. We have the materials for structure, materials for function, and the tools. So first we'll talk about the materials for structure. In the latest design of the steam vehicle, we use bamboo chopsticks as the base. This was because bamboo chopsticks did not burn when we test run it, and it was also the lightest out of all the materials that we used. Number two, we have iron wire. This was used to give it a bit more structural rigidity by twisting the wires and connecting them to the chopsticks. It provided an enough rigid base. Number three, we have aluminum cans. We use aluminum cans to make the boiler, the burner, the wheels, the turbine. So most of it is working because of the aluminum cans. And we also used a PVC tape roll. When observing all the materials that we had, the PVC tape roll seemed like it was going to be the turbine choice for us since it's well balanced when making the turbine. But at the end, we found out that all it did was making the balancing portion of the turbine easier. We use hobby tack to balance out the turbine so it spins nicely. Number five, we have wooden skewers. This was used to adjust some of the things in the steam vehicle to give it more structural rigidity. And barbecue metal sticks. These were used for the turbine and the wheels axles. This was because it was the most smoothest thing that we could have found, and when we assembled everything, it did not bend, which was nice. So number two, we have materials for function. There's rubber bands. We attach them to the wheels just to give it enough bite to the axle, so that when the axle spins for the turbine, the wheels also spin. Number two, we have ethanol, and also number seven, we have lighter fluid. It's the same thing. We use both of these fuel sources so that we could light up the boiler to produce steam. We found out in the end that it was not the best fuel source to work with, but it was just what we had on hand. So number three, we had water, of course, for the boiler to create steam. To attach everything, we used epoxy, metal epoxy, so that it doesn't melt or it doesn't flake off because it can withstand high heat. So super glue and hot glue was just used to tack everything together before we put on the epoxy. So the tools, we have the drills to be making holes in the aluminum cans to make the burner, the wheels, and also the boiler. We had pliers so that we could manage the iron wires, and metal scissors to cut everything to shape. We used a heavy duty metal scissor, so we didn't risk any injuries doing this project. And number four, we found out that inserting water and alcohol into the burner and boiler, respectively, was very hard. So we used a syringe in order to do that. So that's all for this construction of the steam vehicle. Thank you.
That is all from our group. Thank you for listening to our presentation about the mini project, which is the steam engine vehicle.